Unit 5.2 uses the substitution method to find the solution to a system of equations. So this is another way to do it if you don't already have a graph. Drawing a graph is timely and complicated, and if you don't draw it perfectly, finding the intersection is going to be almost impossible, right? So this is a way you can do it without the graph, right? It's called the substitution method. What do you bet you're going to be doing? Substituting, right? A method of solving systems of equations by substituting equations within one another. Alright, so step one, solve one equation for x or y. It doesn't matter which equation, and it doesn't matter which variable you solve for, right? The idea is that we can use symmetrical property. If x equals 12, then we can replace x with 12, right? That's the whole point. Step two, substitute this expression into the other equation and solve for the variable, right? Once you have an answer for whichever variable you chose, right, then substitute your answer into the revised equation from step one. So reuse the first equation that you've already started with and solve for the other variable. So you're literally going to substitute twice. You're going to use one to solve for the other, and then use the answer for that to solve for the first one. It's insane, but it works. Alright, so let's see how that works in reality. Alright, both of them are already in slope-intercept form. Both of them are they already have an isolated variable. They have already solved for y. They did the work for you. So what they're saying is if y equals 4x minus 1, then we can replace y with 4x minus 1. Think about that, right? So if y equals 4x minus 1, then we're just going to replace y with 4x minus 1. So instead of y, we're going to put 4x minus 1, right? We replaced it, we substituted, is equal to 2x minus 5. I mean, that's what this is saying. Y is equal to this, and y is equal to this. So this should be equal to this. Now you just solve for x, right? You want to get the variables on the same side. You remember doing this? All right, this leaves you with 2x minus 1 equals negative 5. And then you want to get the values on the other side. This leaves you with 2x equals negative 4. And then we want to isolate the x. X equals negative 2. Now that you know what x is, go back and put it into this original equation. Right? Now that we know what x is, go back. Instead of 2x minus 5, we're going to replace x with negative 2 because now we know what x is. And we're going to solve for y. Y equals negative 4 minus 5. Y equals negative 9. Right? So your solution, where the two lines are going to intersect, is at negative 2, negative 9. That's the point where they're going to intersect. So we substituted the equation into y, solved for x, and then we substituted the answer for x into the equation and solved for y. We substitute and solve twice. Right? And that one was easy because it was one equation equal to another. Alright, but this one's a little more interesting. Wait, let's go to the next one. I wanted you to do the evens. I almost forgot. Alright, in this one, y, they already have one of the equations solved for a variable. They solved for y here. That means that y is equal to this. That means I can substitute this for the y. Right? So 3x plus 8 times x plus 9. So instead of putting y, I'm going to put x plus 9. And because it's a group, I'm going to put it in parentheses so everybody knows it's a group. Right? And then I'm just going to write the rest of the equation. Equals -5. And now I'm going to solve for x. To do that, I need to distribute 3x plus 8x, because 8 times x, plus 72, because 8 times 9, right? 8 times x gave me 8x, and 8 times 9 gave me 72. I'm going to bring down my equals -5. I'm going to combine my like terms. 8x and 3x have the same variable, so I can combine them. 8 and 3 is 11, so 11x plus 72 equals -5. Now I just need to solve for x, right? Get rid of the constant. Now we have 11x equals -77. Don't lose the negative. Think about it like money, like debt. The cost of something. Divide by 11, divide by the coefficient. X equals -7. 77 divided by 11 is 7. Now that we know what x is, we're going to go back and put it into this equation. The good news is you can put it into whichever equation you think is simpler. Guess what? I think the top one is simpler. Right? So y equals x plus 9. So y equals 2. So my solution is -7 for the x, 2 for the y. This is the point where they were intersect. And if you had used this other equation, you should get the same answer. You don't have to solve both equations unless you want to double check. You should get the same answer if you're right. So let's see if we are right. Instead of x, we're going to put -7. So 3, -7 plus 8y equals -5. -21 plus 8y equals -5. Add 21, which would be 8y equals 16. Divide by 8, y would equal 2. Now I know I have the right answer because it worked in either equation. And that's why when I said you could use either equation, this one was just easier. I used the easier equation. Why wouldn't I use the easier equation? Alright? Again, neither of these is solved for a variable. Solve for the easiest variable. In my opinion, this one is the easiest. You only have to do one step, right? 2x plus y equals -2. I'm solving for y because it's the easiest one. It doesn't have a coefficient. Whatever variable doesn't have a coefficient is your easiest one, right? Subtracts 2x from both sides. Y equals -2x minus 2. Now I know the value of y. I can take the value of y and plug it into the other equation. Okay, so 5x plus 3y, which is -2x minus 2, equals negative 8. Now I just solve for x. Distribute. Negative 6x, negative 6 equals negative 8. Combine my like terms. 5x minus 6x is negative 1x. Negative 8. Get rid of the constant by doing the opposite. Get rid of the coefficient by dividing. X is 2. Now I can go back and put it in either equation. So I substituted this value of y into this equation. And now I'm going to substitute this value of x back into the original. Okay. Right, you get it. Right? Instead of x, I'm going to put 2 plus y equals negative 2. This equation is simpler. I'm just going to use it because it's simpler. 4 plus y equals negative 2. Subtract 4 from both sides. Y equals negative 6. So my solution, my intersection, is 2, comma, negative 6, x comma y, right? It's always x comma y. The x always comes first. The x always comes first. 2 more, I think. Ooh, 3 more. All right. Solving for x. Plus 5y equals 4. I'm going to get rid of this 5y. Solve for the variable that has no coefficients. X equals negative 5y plus 4. Don't forget the positive or negative sign. If it's negative, it's negative 4. If it has no sign, it's a positive 4. You have to have an operator there. Right? Now that we know what x is, I'm going to replace this with this. Right? So 3 negative 5y plus 4 plus 15y equals negative 1. Distributes. Negative 15y plus 12 plus 15y equals negative 1. That's interesting. Negative 15y plus 15y are going to cancel out. I don't even have to blam. Right? They cancel each other out. I'm left with 12 equals negative 1. Remember, a solution is a point that makes both equations true. This is not true. This is not true. Bam. If it is not true, there is no solution, which means that the lines are parallel. Right? These are parallel. There is no solution. There is nowhere they're going to cross. Period. Period. Right. Parallel. Let's move on to 9. Alright, again, solve for the variable that has no coefficient. 2x plus y equals 18. Subtract 2x from both sides. Y equals negative 2x plus 18. Now that we know what y is, we can substitute it into the equation. 6x plus 3y, which is negative 2x plus 18, is equal to 54. Always double check your numbers. If you copy something wrong, you destroy the whole problem. Take your time. Make sure you're double checking and copying your numbers correctly. Distribute 6x minus 6x. Interesting. Plus 18 equals 54. No, not 18. Because I need to distribute the whole thing, right? This is negative 6x, and this is 54. 3 times 18 is 54. equals 54, right? So again, we have an equation where it's 6x minus 6x. Those are opposites, inverse operations. Anything plus its opposite cancels. It's 0. They cancel out, right? So what are we left with? We're left with 54 equals 54. That is a true statement, but there are no variables left. That means it's infinity. That means these are literally the same line. If we put them both in slope-intercept form, they would probably be the same equation. They're the same line. It created a true fact that has no variables. That's infinity. I'm glad they gave me an infinity and a no solution. All right? Solve for the variable with no coefficient. Be careful. Because this is a negative y, it does have a coefficient of -1. So you're going to have to get rid of that. If you're not comfortable getting rid of that, solve for the other variables. Let's solve for this one this time. 5x plus 2y equals 5. You want to solve for x or y? I agree. I think we should solve for y, because we have a lot of practice with that. But it's okay if you want to solve for x in this case. It tells you could solve for either variable. Right? So let's solve for y. 2y equals, this one's going to have a weird fraction. Why do I always get the one? It's alright. It's alright. It's good to practice. Solving for y. Look at that. That's so weird. I don't even know if I like that. I don't even know if I want to continue with this. I don't even know if I want to look at that. My goodness, what am I supposed to do with that? My goodness. This is why you go for the easier one, because that's ridiculous. I'm not working with that. I'm not. You're welcome to try to handle that. I don't even want to tax your brain in that manner. I don't even want to give you the chance to make those mistakes. Alright, so instead I'm going to do what I said to do, right? Solve for the one with almost no coefficient. Right? Let's see what happens when I do that. Let's see if that makes it easier. It might not make it easier. They might want this one to be hard, and we might just have to suck it up. Right? Subtract 3x from both sides. Negative y equals negative 3x minus 8. This was definitely going to be easier. Get rid of that negative. To get rid of the negative, you're dividing by -1, which means you're changing all the signs. So it's going to be y equals 3x plus 8. Basically, we just changed all the signs. And that's definitely easier in my opinion. Now that we know what y is, we can substitute it in. 5x plus 2y equals 5. Distributes 5x plus 6x plus 16 equals 5. Make sure to multiply everything inside by what's outside. Make sure you distribute it to everything inside the parentheses. Combine your like terms. Solve for x. Solve for the missing variable. Yeah, easier. Now, if x is -1, we can plug it into either equation. Again, I suggest the first equation. Don't lose the negative. So my intersection, my solution, -1, 5.